Load the simulation and run it multiple times until at least 600 simulated seconds have elapsed. Record the resulting data in the two following tables. Okay, so simulation. We're going to open the simulation that Sean has made for us, and that will give us the data that we need to put in here. So here's the simulation. And we can do real time, 600 seconds. That's a lot of time. We're going to run it turbo. Okay, cool. So we have a, an artificial yellow sample of radioactive material here. And essentially these black squares are the atoms that have decayed over 30 seconds. So here in the left side, we have a table of time and number of decays per time interval. So we had 320 atoms decay. Over here, we have the remaining of unstable atoms. So I think that's for your first graph, and this one is for your second graph. We started out with 2,500, and after 30 seconds, we only have 2180 left. All right, so I'm just going to run turbo again, and I'm just going to keep clicking it until we hit 600 seconds. And there we go. All right, great. We have our data. But number 3 says that we have to fit an exponential decay curve. All right, and we can only do that with Pasco. You may have used the Pasco software in these labs before. So I'm just going to do that for you. So here's the table. I'm just going to input all the data. And we have our unstable atoms graph here, and we have our number of decays graph here. Okay, so here's our remaining unstable atoms. I'm just going to put those in there. Cool. And now I'm just going to jump right on over to this other graph. Here we go. All right. No data right there. All right. Well, for the number 3 of activity 2, we are going to apply a fit curve. Go ahead and find which of these equations looks like the equation you have on the right. It's this one right here. Okay, so we can see that A corresponds to R naught. We can see that E comes right after the A, and E is to the negative BX. All right, in our case, B is lambda. X would be on the x-axis, and in our own equation, T would be on the x-axis. So T has to go with X. It doesn't really matter where the negative sign goes. It's like a -1. And so that means B goes with lambda. So lambda is B and R naught is A. Okay, so I'm going to click that and let's see what we get. So A, here we have A is 2,490, and B is 0.0043. I'm going to go ahead and do the same over here while you're doing that. And we have the same thing.